Question 28. The densities of two different liquids, P and Q, are in the ratio 38 to 44. Okay, so 38 will be the P and 44 will be the Q. We know that because that's the order they're written in. The mass of 1 centimetre cubed of liquid Q is 1.1 grams. Mass and density are not the same thing, so we're going to have to think about our mass and density formula in a minute. And 10 centimetre cubed of liquid P is mixed with 30 centimetre cubed of liquid Q to make 40 centimetre cubed of liquid R. Work out the density of liquid R. Okay. So, we've got a mass and we've got a volume. And you need to know the density. Okay? They give you a clue a bit further down the page. Density, grams over centimetre cubed. So I'm just going to write that down. So density and why is that relevant? Well, we don't have units for just no reason at all. They serve a purpose, and that is they tell you what that number represents. Grams over centimetre cubed. So if I think about my density triangle, I know that my mass is going to have to be on top for it to be grams divided by centimetres cubed. So mass, that's in grams, and then density is going to have to be on the bottom, and so is volume. So, and our volume is in centimetres cubed. So mass, density, volume, MdV. If you're not familiar with the triangle, you still could work it out using that unit. So the first thing I want to do is work out the volume, sorry, I've got the volume, work out the density of liquid Q. Which they've made really easy. It's going to be the mass, which is 1.1 grams, divided by, because we're trying to find the density, cover up the density, grams divided by centimetres cubed. So, first step, density of Q is 1.1 grams divided by 1 centimetre cubed, which is 1.1 grams per centimetre cubed. So that's liquid Q. The ratio of the densities are P to Q, where P is 38 and Q is 44. So P and Q, 38 to 44. And we know the density in this case is 1.1. So if I want to change from Q to P, what I need to do is divide by the one on the same side, so divide by 44, and then multiply it by the one on the other side, so multiply by 38. Okay, and that's a general rule for using a ratio: divide by the one on the same side, multiply by the one on the other side. And I'll need my calculator for that, although I'm pretty sure it's working out without. So 1.1 divided by 44 times by 38, and that gives me, comes up as 19/20, but we know to press the S to D button, 0.95. So, the density of P is 0.95. Grams per centimetre cubed. Now the issue we've got is that 10 centimetre cubed of P is mixed with 30 centimetre cubed of Q. and that gives us to make 40 centimetres cubed of liquid R. So we need to work out the weight, the mass of liquid R. Because we know what its volume is, so we need to work out its mass. So mass is going to be, if I cover that up, density times volume. So just to split that up, we're now doing the mass of Q, which is going to be 1.1 multiplied by the volume we're using, and the mass of Q that we're using is 30, so 1.1 times 30, and the mass of P, which is going to be 0.95 times by 10. So again, I can use my calculator, or I'm pretty sure I could work it out without. So 1.1 times by 30 gives us 33 grams. And then 0.95 times by 10 is 9.5 grams. Okay? And so when I've got the mass of R, that's going to be the total of those two. So 33 plus 9.5, which is 42.5 grams. Nearly there. Last step, find the density of R. So if I cover up density, I'm doing mass divided by volume. So that's 42.5 grams divided by the volume, which is 40 centimeters cubed. And that will be, one moment, 1.0625 grams per centimeter cubed.